Hello there, welcome back to the new lecture. So in this lecture, we have to start the heat load calculation in Revit. So for heat load calculation, here we have to follow some step. So in that, the first point is what? We have to create the space schedule for heat load calculation. It means what? Before starting the heat load calculation, first step you have to follow what we have to create the space schedule for Revit heat load calculation. Same thing in previous lecture we have seen that how to create the space schedule for school building. So in that schedule we have given the detail of a school building. Same way we have to create the space schedule for Revit heat load calculation. So whatever information you want to see that schedule in that schedule, you can see it. So how to create space schedule for Revit heat load calculation? Same way, hit on analyze tab, report and schedule panel, hit on schedule or quantity. Under category you have to select the spaces like this, and now the name, write down space schedule for Revit heat load calculation. I have written the shortcut HLC heat load calculation, then finally hit on OK. Now in that schedule which you are creating for Revit HLC, what parameter you want to see? So from the available field, suppose I want to see the level first of all, so I have select the level, add it. Now I want to see the name of each and every room in the schedule, so okay, add it, number. Now what you want to see? I want to see the area also in that schedule which I am creating. So where is area? Select the area from the available field and add parameter. Now I want to see the space type also. Okay, so where is the space type? Hit and add it. Now I want to see the calculated cooling load, means after the heat load calculation we have to see the calculated cooling load also in that schedule. Okay, so where is calculated cooling load? Okay, select it from here, add it. Then I want to see the calculated supply airflow. Okay, select that and add it. After that I want to see the condition type. Okay, in which room you want to give the condition air, in which room you want to give unconditioned air or ventilation. So how Revit will identify? So that is why I will show you what is the use of condition type. Add it. Now let's say in this schedule only I want to see the number of people for each and every room, how many number of people are coming. So select the number of people, add it. Then I want to see the outdoor air per area also, outdoor air per person, so add it, select it and add it. Now let's say okay, we have added everything. Now in this schedule only I want to see the fresh air also, whatever we are calculating. I want to see the fresh air CFM value also in that schedule. But when you search in available field you will not get any option of fresh air. So okay, if you don't know, there is no option for fresh air, but we know the formula to calculate the fresh air CFM. What is the formula? Fresh air CFM is equal to, in bracket, what? Outdoor air per person into number of people plus outdoor air per area into area of that space in square feet. So if you know the formula, so see what you can do. Here you have to hit on this thing, new parameter, and one option is given, add calculated parameter. So hit on add calculated parameter. Here you have to write down the name, like fresh air I want to see. Now you want to apply the formula for fresh air, hit on formula. Now fresh air will come under which discipline? In HVAC only, and the type is airflow only na? Now here you have to apply the formula. What is the formula? In bracket, hit on this three dot. Whatever you have added here in schedule field, you will get the option. From here only you have to select. So we know that formula is calculated outdoor air per person, so select it, into number of people. So again hit on three dots, select the number of people from the schedule field. Okay, then close the bracket, again plus, open the bracket. Next in formula, outdoor air per area, select it, into area of that space. So again hit on three dot, area. Okay, and close the bracket. So hit on OK. Now here see the fresh air is also added. So whatever fresh air you want, you will get in this schedule which you are creating. Same thing, Here I want to see in this schedule only, I want to see the return error also. So but return error also, when you search in an available field, you will not get the return error anywhere. So okay, but we know the formula to find out the return error. What is the formula? Yes, return air is equal to calculated airflow minus fresh air is your return air. Okay, so again you have to hit on add calculated parameter. Now write down return air. Okay, formula, I want to apply the formula. Discipline HVAC, type airflow. Formula is what? Cooling airflow. So okay, hit on this three dot. Already we have added calculated supply airflow. Okay, minus fresh air. Okay, minus, write down the minus and hit on three dot. Where is fresh air? Fresh air. Okay, hit on okay. Now see, the return air is also added in schedule field. After adding this all parameter, you have to hit on okay. See, now the schedule is ready. Whatever you have added, it is here. Now we have to do the setting. Already I have explained you. I want to see this level in header. I want a blank line and footer after completion of each and every floor. So okay, in sorting or grouping, hit on edit type, sort by level. I want to see the level in header. I want footer. In that footer, I want to see total only, then blank line. Okay, now see, after that I want to hide this ground floor which is repeating, because already the level is shown in header. Okay, and I want to see the total area, whatever. So in formatting, you have to hit on that. You want to hide the level, select the from the field, you have to select the level, and in field formatting, check hidden. Okay, now see, the level is hide. Now I want to see in this footer only, I want to see the total area of each and every floor and whatever you want to see. So just hit on formatting, select the area. From here you can select calculate total, hit on OK. See, now you will get the area for each and every total area. Same thing, suppose in formatting only, hit on OK. I want to see the total calculated cooling load for each and every floor. Okay, select it from here, calculate total. Okay, so here you will get the total calculated cooling load, but here calculated cooling load is not shown. Why? Because we have not done the heat load calculation. After heat load calculation, you will get each and everything here. In which unit it is showing? BTU per hour. If you want to change the unit, you don't want to see the calculated cooling load in BTU per hour, you want to see in ton. Okay, so for that you have to use the command unit command. Okay, and do the changes that I will show you how to do. I want to see the supply air CFM here. Okay, so in formatting, select the calculated supply air and I want to see the total for each and every floor. Calculate total. Okay, okay, after doing this thing, after doing this all settings, see, I want to change the unit. As I told you, this calculated cooling load I want to see in tonnage. Okay, so from here, close this space schedule for Revit HLC, because already that schedule is safe in project browser. See, space schedule for Revit HLC. If you want to open, you can open it from here. First, I want to change the unit of that cooling load. So just use the shortcut UN for unit. From here, you have to select the discipline HVAC. Okay, cooling load. See, the unit it is written BTU per hour, but I want to change the unit of cooling load. So hit on this, which unit you want. I want to see the ton of refrigeration. If you want to see the symbol also, you can see it, otherwise none option is also given. Okay, okay, okay. Now when you open the space schedule for Revit HLC, double hit on that. See, now here you will get the calculated cooling load value in ton. Getting? In this way you can change the unit also. Now see, the important thing is what? Okay, here see, the room name is given, number, area, space type. So what you have to do, how the Revit will identify that you are doing the heat load calculation for which room. So in space type you have to enter the space. Suppose the first room in ground floor, it is account department. So in space type you have to hit on this three dot. Here in space type setting dialog box will appear. First you have to search account department room is given anywhere. If it is given, is okay, otherwise any space just near about account department. So it is a bank, just like a banking activity area. Can I select this? Yes. So as per this space only, Revit will take this all parameter, energy analysis, area per person they have taken, because sensible heat gain per percent, whatever lighting load value they have taken as per your space. Okay, so select this space. Okay, same way you have to do for each and everything in which room you want to give the condition air. Now come here in next, condition type. Why I have added in schedule condition type? Because how can Revit identify in which room you want to give condition air, in which room you don't want to give condition air? So here you have in condition type, here you have to hit on three dot in this drop down list. Here everything option is given. If you want to supply the condition air, cooled air, here in cold account department, select the cooled. You want to supply the heated air, select the heated, both heated and cooling, so heat and heat cool. If you don't want to supply the condition air, so you have to select the unconditioned from here. You want to give the ventilation, okay, hit on vented. Okay, so in this way Revit will identify. Okay, so suppose in account department the room is cooled, I want to supply the condition air. In corridor, no, I don't want to give the condition air, so unconditioned space I have given. In principal also I want to supply the condition air. In reception, so from the list you have to do this setting like this. Okay, in which room? So in washroom, no, it is an unconditioned space. Library, yes, cooled space. Electrical room you want to supply, no, I want to give the ventilation, so I have selected vented. Staircase is an unconditioned space. Same way for first floor, you have to come here. For section A, cooled. Section B, here also we have some room. Okay, in that all room I want to supply the condition air, but in corridor this is an unconditioned space. Staff room, cooled air. Conference also cooled. Then many other option. Section B, cooled air, cooled. Okay, so this setting you have to do. Like in women washroom, it is an unconditioned space. Men's washroom is also unconditioned space. Electrical room I want to supply ventilation. Staircase is an unconditioned space. Same thing come here in second floor, and just in which room you want condition, just from here you have to. Okay, so in condition type, this is the importance of condition type. That is why I have added this. Remember, in corridor I don't want to supply the condition air. Okay, so during the heat load calculation you have to remember this all option, whatever you are writing here, it is unconditioned and condition. Okay, same thing for space type only. If you want to supply the conditioner in principal room, so here you have to select the principal room, because as per space only Revit will identify. Okay, hit on three dot, write down principal, whatever you want. So search it if it is there. Okay, if it is not there, so little around that near about any space is given. Okay, I am selecting office space, just like a principal only. So see, office enclosed, office open, so just select as a office enclosed. As per that you will get the detail here, energy analysis. Hit on OK. Okay, so now the Revit will identify. You have to fill all this detail. I have left it, but you have to fill it. Okay, now here you can see fresh air CFM is showing. Why? Because everything we have entered a number of people according to space type. Like you have selected bank activity, so as per that you will get the number of people, outdoor air per area, outdoor air per person. Then area already it is given, so that is why. See, means in account department how much fresh air we need to supply, 39 CFM. But for return air option is not showing, because we have not done the heat load calculation, means we have not calculated the supply air's flow and cooling load value na. So that is why here there is no option. When you do the heat load calculation, after that you will get each and every detail in this schedule. Okay, that is why the first step is what we have to create the space schedule for Revit heat load calculation, and from here you have to close it. So discuss the next step of heat load calculation. So in this step we have to see how to change space tag for Revit heat load calculation. Let's say here when you open the plan view for, let's say for example, ground floor plan, here I have opened. Now if you want to change the space tag, okay, suppose here in space tag only the space name is written, for example account department, library, examination cell. Suppose in this tagging only I want to see the supply airflow value, cooling capacity value also. So how we can change this space tag, that we have to see. Okay, so for that select any of the tag from the drawing, modify tab, mode panel, edit family. Hit on that, edit family. Now from here you have to select the space label. Then here you will get one option, edit label. Once you have hit on edit label, here you will get the edit label dialog box. Now in your tagging, which parameter you want to see, so you can add it from here. So from the category parameters, select the parameter which you want to see in your tagging. Suppose I want to see the calculated cooling load value in tagging. So from here I have selected that. Now see, here you will get the option add parameter. Hit on that. See, name is already given in tagging. You have seen. Okay, I want to see the calculated cooling load value also. So here I have added that. Same way, now I want to see the calculated supply airflow value. Just select it, add it. Now when you add the supply airflow value, automatically here they are giving 320 CFM. So I just select 0 CFM, okay, because we don't know na here. So after the heat load calculation, you will get both of detail, cooling load and supply airflow detail. Okay, so we have done that. We have added this thing. Now finally hit on apply. See, directly when I'm trying to hit on apply and okay, see, you will get the tag like this. First in your tagging you will get the space name, after that you will get the cooling load value, after that CFM value. But you don't want to see like this. I want the space name first, then below that I want to see the calculated cooling load value, and below that I want to see the supply airflow value. I don't want to see like this in parallel arrangement. Okay, so okay, for that you have to do the setting. Hit on edit label. Here you have to check the break. When you check the break and hit on apply, okay, now see, first you will get the space name, like let's say account department. Below that you can see the calculated cooling load value, and then supply air CFM value. Okay, let's say here one more option is given. Come here, edit label, prefix and suffix. What do you understand by prefix? Remember, suppose before this calculated cooling load value, or before the space name, or before the supply air CFM value, if you want to write something, if you want to see and if you want to write something before the calculated cooling load value, okay, so that you have to write in prefix. Let's say I want to write TR is equal to, before calculated cooling load value, I want to write down the TR is equal to, TR stands for ton of refrigeration. Okay, and before this supply airflow value, I want to write down the @ like this. So I have written that. Same thing, if after this parameter, like after calculated cooling load value, after supply airflow value, you want to see something, you want to write something, so in suffix you have to write down that. Finally hit on apply. Okay, now see, first you will get the space name, then whatever cooling load you have done, you have calculated, and then @ supply air CFM value. Finally, after doing this setting, come here in file tab, save as family, save it to the desired location. So I want to save in desktop, so hit on desktop and give the name. Suppose I am giving space tag for Revit heat load calculation. Okay, so I have given this name. You can give the full name, heat load calculation, space tag for Revit heat load calculation. Now I want to save in desktop, select the location from here and save it. Okay, so after saving, here you will get the option load into project and close. Hit on that. Now the tag is loaded, but if you want to see that tag, so come here in ground floor. See, we have changed the space tag, but see, can you see here the space tag is changed? No, we cannot see the supply air CFM and cooling load value here. Okay, so for that you have to select the tag from the drawing. Okay, this existing tag you have to select from the drawing and replace it with updated one. So here I am just selecting all of the tag in which room we have to supply the conditioner. Come here in properties palette. Here you can see the name the space tag which you have saved in your desktop, it is given here. Space tag for Revit heat load calculation. Just select the existing one, replace it with updated one. Now see, here in tagging you can view the TR, means cooling load value, supply airflow value also. Same for other level like first floor. Come here. Here also we have to select the existing tag from the drawing. Only that tag you have to select in which room you want to supply the condition air. Okay, don't need to select the women washroom because in this room we are not supplying condition air. Okay, so select the existing tag, replace it with updated one like this. So here remember, it is written non-computed because we have not done the heat load calculation. When you do the heat load calculation, after that whatever tonnage and supplier CFM is coming for section A, section B, you can view that here in this tagging. Okay, come here for next floor, second floor, select the existing tag like this and then replace it with updated one from property palettes. Hit on that. Now see, the tag is ready. So in this way we have to change the space tag for Revit heat load calculation. Here we have to see the next step of heat load calculation. In that we have to see how to create HVAC zone. How Revit will identify that which type of unit you are using, means machine. Okay, suppose let's say if you want to use the AHU, air handling unit, with the help of that AHU you want to supply the condition air in each and every floor. Okay, so for that we have to create the HVAC zone. Suppose let's say here I am using only one AHU which we have to place above the roof. Okay, I am planning for my project. So with the help of one AHU only, we have to supply the condition air in ground floor, whatever space is there, in first floor space and in second floor space. You can do like this also for separate. You can select the separate AHU for ground floor, separate AHU for first floor and second floor. Okay, if you want to use the FCU, ceiling suspended FCU, okay, you can use that also. So here just I am planning that I am using the AHU. With the help of that AHU, which we have to place above the roof. Okay, with the help of that AHU, we need to supply the condition air in ground floor also, first floor and second floor. Okay, so for that we have to create the HVAC zone. So see, so for that hit on analyze tab, spaces and zone panel. Here you will get the option of zone, define HVAC zone with a project. Hit on that zone. Now here you can see in properties palette, write down the name. So I'm writing, suppose I'm using the same AHU na, which we have placed in roof floor. So RF AHU I have written. Okay, with the help of this AHU only we need to supply the condition air in all spaces. Okay, either it is in ground floor or first floor or second floor. You can use the separate AHU also. So give the name, hit on apply. Now the name is written. Now you have to select the number of space line from the drawing. How to select? See, like this. Hit on that. In which space you want to give the condition air, just select that space line from the drawing like this. Okay, so only in ground floor only these 5 spaces I want to supply the condition air, so I have selected. Then hit on finish editing zone. Now when you take the cursor near to that, see, it is showing this all 5 room you are supplying condition air with the help of roof floor AHU. Okay, now Revit will easily identify, okay, you are supplying condition air in this all 5 room with the help of AHU. Same way, come to next floor, first floor. Here also we have to create the HVAC zone. So analyze tab, spaces and zone panel, hit on zone. Now here you can give the name. So I'm using the same AHU, so ground floor AHU, same name I have written here, apply. Suppose if you are using separate AHU for each floor, okay, so as per that you have to write down AHU1, AHU2, but I want to use the same AHU. So when you write down the same name, here you will get one warning, element have duplicate name value. So okay, so I want that same name. Okay, hit on that. Now select the number of space line from the drawing in which room you want to supply the condition air. Let's say section A1, section A2, section A3, then staff room also, conference hall, and section B2, section B1. Here also we have one section B3. Okay, select it, hit on finish edit mode. Now when you take the cursor, see, it is showing We are supplying conditioned air in this all room with the help of same roof floor AHU. Okay, come to next floor now, second floor. Here also we need to create the space HVAC zone. So analyze tab, spaces and zone, hit on zone. From here, just in this properties palette, write down the name. Same name I am writing, AHU, roof floor AHU. So when you hit on apply now, you will get the warning. Okay, but I want same name, so hit on OK. Select the space, number of space line from the drawing like this. Chemistry lab, section C3, then seminar hall. After that, section C1, section C2, and then section C4. Then finish edit mode. Now when you take the cursor, see, in this all room we are supplying conditioner with the help of AHU. Okay, so in this way you have to create the HVAC zone. Now we have to start the heat load calculation. So all of you know that heat load calculation in Revit are crucial for several reasons. Okay, because accurate heat load calculation help determine the heating and cooling requirement for a building. So this information is crucial for sizing HVAC systems appropriately and ensuring they are efficient and capable of maintaining comfortable indoor condition. Okay, and with the help of accurately calculating the heat load, designer can easily optimize the HVAC system's size and capacities. Okay, so there are several reasons, okay, for heat load calculation, and the main is we need to find out the main purpose is what, why we are doing heat load calculation. We need to find out the cooling load and supply airflow, because based on supply airflow only we have to do the duct sizing, everything. Okay, so let's start here. So for that, the first option, first of all, if you want to start the heat load calculation, so just come here in analyze tab. In analyze tab, report and schedule panel, here you will get the option of heating and cooling load, or you can use the shortcut also, LO. Hit on that. Okay, so when you hit here, you will get the heating and cooling loads and see the preview of your school building. Okay, zone is showing here. Only single zone we have created with the help of one AHU. We are supplying condition air na. So here you will get two tab, general tab, detail tab. Okay, first come here in general tab. In general tab, you have to fill this all detail. First write down the building type, which type of building we have. So we have a school building. So from the list you have to select the school or university. Then location, for which location? Let's say I am designing for Hyderabad location. Hyderabad is in India. Okay, and you know that the design condition all you will get from the ASHRAE handbook. So but here don't need to use that. Here only you have to write down the location. Automatically Revit will take that. As per that location they will give you the everything. So okay, so location is I am designing for Hyderabad city, which is in India. So from here you have to hit on three dot. See, project address, define location by internet mapping service is given here. You can easily define the location by internet mapping service also. Okay, otherwise here weather, everything you will get as per that location. Okay, so here just I am just trying to write the Hyderabad. See, it is given or not, Hyderabad, and just search it. See, some error is coming. An error has occurred in the strip on this page. So do you want to continue running a strip on this page? Okay, we are trying to run. So okay, so you will get the internet mapping service. Just write down the city, you will get that detail. Okay, so the project address cannot be located via the internet mapping service. Okay, to resolve the problem, make sure you are connected to the internet. If you have internet service, select the search button to locate the project address. Okay, so remember, if you have a internet service, so it is easy for you to just locate, give the location. So write down the name of your city and search it, you will get it. Okay, then ground plane. Ground plane is what? Remember, in design and architecture, the ground plane refers to the level surface or floor level upon which a structure or building is situated. Okay? It represents the immediately horizontal surface of the ground where construction, landscaping or any form of building take place. Remember. So here in our case, the floor is started from ground level. So from here you have to select the ground floor. Okay. Then project phase. Here it is a new construction, so you have to select the new construction, otherwise existing one is also there, so it is a new construction. Okay, now the next option you can see here, it is given silver space tolerance. Still, silver space tolerance means the gap between the false ceiling and slab. Architecture will give you the MEP service gap, okay, to run your HVAC services like ducting and plumbing, piping, firefighting pipe and cable trays, everything. Okay, so that silver space tolerance, or you can say MEP service gap. So let's say in our project we have a 3 feet gap. Okay, so here I have given 3 feet. You have to check the gap. Okay, how much gap is given in your architecture drawing. Okay, then write down the detail. So here I have written 3 feet. Now come here, next one, building envelope. So in building envelope, hit on use function parameter from here. Okay, then building services, which type of system you want to use. Here you can see the VAV system, single duct VAV, dual duct. Okay, so we need to supply the condition with the help of AHU. So system I am selecting VAV. Okay, so what is VAV system? Variable air volume system. CAV system, constant air volume system. What is VAV? Single duct, dual duct. All this already I have explained you in previous lectures. You can just read that lecture, all air distribution system. In that I have explained you each and everything. Okay, in all air distribution system I have discussed the types of all air distribution also. Generally we have a 4 types of all air distribution system. In that you will get each and everything, the detail of about VAV, CAV system, and other option is given. Okay, so different option is given. Here I am selecting VAV single duct. Single duct means if you are using single duct to supply the conditioned air in each and every space, so you have to select the single duct. Sometimes we are using double duct. Suppose in some room you want to supply the hot air, in some room you want to supply the cold air, so we are using double duct. So on that time you have to select the VAV dual duct system. Okay, now come here is schematic types. So in schematic type you have to select the it is by default building only, just leave it. Okay, building. Now building infiltration class. Now what is this building infiltration class? Remember, the building infiltration class refers to a classification system that defines the air leakage or infiltration rate of a building. Okay, so here you can just select the class loose, medium, tight. So I am selecting medium infiltration class. Now the report type is standard. After filling this detail, what you have to do, just come here. After filling this detail in general, you have to come here in next tab, details. So in detail, see, you will get the building model, everything. So from here first you have to select the default. In default, when you select, now see, hit on plus sign. See, in default you will get that space in which you don't want to give the condition air. See, corridor, washroom, electrical room, because this all spaces is an unconditioned space, na? So automatically by default Revit will place this all space in your default. So what you have to do, select the default from the list like this. Okay, select it, just minimize and select it. Now here you can see heating information is also given, cooling information is given. So I want to calculate the cooling load. If you want to calculate both, so as per that you have to write down the detail. So under this cooling information, okay, when you hit on this 3 dot, zone cooling information, see here you will get the cooling information dialog box. First you have to write down the cooling set point. So we know that we are designing for Hyderabad, and in default whatever space are there, it is an unconditioned space. We don't need to supply the condition air. So okay, just write down cooling set point. So when you search na in Ashtray handbook, So you will get for Hyderabad location, dry bulb temperature is 107. So I'm writing here same 107 degree Fahrenheit. And when you come inside the room, outside dry bulb temperature is 107. But when you come inside the room, which is unconditioned, so what is the cooling air temperature on that time? Little bit less than outside. So how much less than? As per HRA, 5 degree Fahrenheit less. So here you have to write down 102. Okay, 107 minus 5 is 102. Then finally hit on OK, like this. Getting? After that, you have to select all the HVAC zone from the list. See, roof, floor, just select it. All the HVAC zone from the list, and come here, service type first. So select it, which we are using VAV single duct na? So select that service type here. In cooling information, just hit on 3 dot. Now here you have to write down the cooling set point. So as you know that as per ASHRAE, for human comfort always we have to maintain the temperature how much in degree Fahrenheit? 76 plus minus 2 degree Fahrenheit. So I am taking here 76. Now cooling air temperature. When we are supplying conditioned air from the AHU, so cooling air temperature is around 56 plus minus 2 degrees Fahrenheit. Okay, so here I am writing that. So when this 56 degree Fahrenheit temperature air, cooling air temperature will enter the room, automatically some amount of air, hot air is there inside the room. So both will mix together and it will be around 76 to 78 or 74. Okay, so 56 I have given here. Then finally hit on OK. Okay, in this way you have to fill the detail. Now here you will get one option, hit on save setting. Now again you have to open the heating and cooling load. So in analyze tab only you will get the option what in schedule, report and schedule. Here the heating and cooling load option is given, hit on that. Now finally, because already we have given the detail everything, so you are there. After that you have to hit on calculate, just hit on it. So when you hit on calculate, now the heat load calculation, all result you will get here automatically. See, the load report is shown here, project summary, building summary, everything, zone summary, and see whatever is default spaces in which you don't want to supply the condition air. Because see here, if you remember, I have for electrical room I have given vented, so that is why the ventilation everything you will get from here. We don't need to supply the cooling air, so that is why it is written dashed. When you come in zone summary of roof, floor, AHU, so here whatever space is given, account department, principal and everything, see their area, volume, peak cooling load value is also given, cooling airflow value is also given, heating airflow value, because we have not entered any detail about heating, so that is why it is showing 0. Okay, so cooling load we are calculating, so that is why for heating you can just fill the detail of heating load. Okay, so same other remaining space you will get here for second floor. Okay, so for each and every space you will get the cooling load value, cooling airflow value. Okay, based on this airflow you have to do the. Now from here just close the load report. Now if you want to again open that load report, so automatically that will save in report in project browser. When you come here in report, see the load report is saved, just hit on plus sign, open that report if you want to see. Okay, so detail you will get from here. Now after doing heat load calculation, when you come in the floor plan, let's say ground floor, see now in tagging you can view the TR value, ton of refrigeration means cooling load value, and see supplier CFM value is also given here. Can you see here? Tell me. In this way, we have to do the heat load calculation in Revit. So in previous lecture, we have seen how to do the heat load calculation. Now suppose, let's say, if you want to transfer that heat load Revit heat load calculation report into HAP software, so that is also possible here. How you can transfer the Revit heat load calculation report into HAP software? So I will show you that also. See, here already we have done the heat load calculation, you know that, and report we have here. See load report in project browser. Okay, So if you want to transfer this report into HAP software, so first you have to go to 3D view first. Open the 3D view like this of your school building. Now our application menu, here you will get the file tab. Just select that. Export option is given here. Just take the cursor near to export. Here you will get one option, GBXML. So select that. From here you will get the expose GBXML. From here what you have to do, you have to check use room and space volume, okay, like this, and then finally hit on OK. Now here you will get the detail of heat load calculation. Nothing to do, just you have to hit on next because already we have done that. Okay, after that save it to the desired location with the name, whatever name you want. Suppose I want to save it in desktop with the name Revit heat load calculation. Okay, Revit heat load calculation. I have saved that report in desktop with the name Revit heat load calculation. Now save it. See, it will be saved in which file? File extension name is .xml. Save it. Okay. So now you have to open the Revit HAP software. Okay. So here I am just minimizing this. See, here I have opened the HAP software. Just hit on OK. After that again you have to hit on OK. Here is some data. Or you want to open the new project. If you want to open the new project, hit on new project. And suppose if you have already saved any project, you want to open the saved project, you can open it from. Okay. So suppose here you will get the different option, you can see. So okay, suppose I have selected new, hit on new. Then from here always select the latest ventilation standard from the list. Okay, so whatever latest is given you can select it, and here some general data in which unit. Okay, you can change the unit and everything from here, measurement unit and everything. Okay, so I want to work in because we are working in imperial unit, so I am selecting English only. Okay, if you are working in metric unit, select it from here, hit on OK. Now see, you will get the HAP software user interface. Okay, now what you have to do, you have to import that GBXML file here in HAP software. So for that, in project, see here you will get the project, hit on project. From here you will get the option import GBXML file. Select that import GBXML. Now where you have saved that file in desktop, if you remember, with the name Revit heat load calculation, select that file from that location where you have saved and open it now. Now see, here the file is imported. If you want to confirm, see, do you want to display translation report? No, hit on no. So now see, if you want to confirm, see, when I'm just hit on this space, see, each and every space you can see here in which we need to supply the condition air. And if you want to see the detail of this space, that also I will show you. Just suppose in spaces I have selected account department, I want to see the detail of account department, double hit on that account department. Now see, in general, here you can see the space property. In general, space name is written, floor area, ceiling height, whatever, 10 feet only. Now we have selected, if you remember. Then from here you can give out the name. So here we have to do the some setting, because remember in Revit heat load calculation is not 100% correct. Okay, because like for example, Revit will not take all the detail. Let's say partition. Suppose in your project, if you have a partition wall means the wall which is coming between condition and unconditioned space. That wall is called as a partition wall. Suppose if you have a partition wall, you know that if any wall is there between condition and unconditioned space, so heat will always transfer from high temperature body to low temperature body. So means the unconditioned space heat will transfer into your conditioned space, so that heat will also add up, but Revit will not take that heat. See here, any option is given? No. So when you transfer the Revit heat load calculation report in your HAB software. So you have to do some changes. Okay, and if you remember, I have not done the internet and mapping services also. Okay, if you have an internet, so you can easily just write down the location, you will get it. So here first thing is what you have to come here and see the location weather. In weather, when you double hit on this weather property, from here you can change the region and everything. Okay, so if you are designing for Hyderabad, as per that you have to write down the details. So Hyderabad in Asia Pacific, location is India. So from here you can select the location India. Now city, so some of city is given here, but Hyderabad is not given. So okay, if it is not given, if you are selecting the given city, so automatically based on that city, HAB will give you the latitude, longitude, everything. But suppose if any city is there, like let's say Hyderabad only, there is no option for Hyderabad, so you have to manually you have to type Hyderabad like this. Okay, type the Hyderabad and manually you have to write down the detail. Once you have typed, now what is the latitude of that Hyderabad, longitude, each and every detail we have to write down. Okay, so that I will show you how to edit this all detail. Okay, so for that what you have to do here, just open the Hyderabad. Okay, suppose this detail, the properties of air, which is showing here. If you want to find out the properties of air, so for that what you have to do here, you have to open the ASHRAE handbook. So from the ASHRAE handbook you will get each and every detail. Okay, as per your city you will get the properties of air, like latitude and longitude. So I will share you and I will show you that also. So before that, see here, just I am writing here latitude of Hyderabad. When you see in this ASHRAE handbook, now you will get around 17.86 latitude, and longitude of Hyderabad is around 78.47. Okay, so write down that 78.47. and elevation of Hyderabad means altitude from sea level is 1788 feet. Okay, this all detail I am taking from ASHRAE handbook only. Okay, summer dry bulb temperature for Hyderabad is 107, so I am writing a 107. Wet bulb temperature is around 78. Okay, daily range of Hyderabad is 14 degree Fahrenheit. Winter dry bulb temperature is 55 degree Fahrenheit and constant wet bulb is 48. So you have to fill this all detail. Okay, now here in design, see LG calculation month, in which month you feel more hot, so that month you have to select from here. Suppose I am selecting May to July. Okay, let's say, and finally you have to hit on OK. So here, okay, weather property you have done, because see, remember, in I have not selected because I have not internet, that is why the internet in mapping service is not shown in Revit. But if you have an internet, so you will get that location. Now come to spaces. Here you want to do the you want to add some, so just hit on account department. Here suppose in general, nothing to do, outside ventilation, here you have to select the space. So it is account department, because see by default it is given CFM per person taken Revit 4.7 0.06 CFM per square feet. So you have to select the room near about that. Account department is given here from the list. Let's say here any account department or related to that, like banking area. Yeah, see, bank, fault and safe deposit. Okay, so if account department is not there, select that. As per that you will get the CFM per person value, CFM per square feet value. Now in internal you will get the each and everything. Already we have entered that detail. Now here also you will get the detail a roof. So roof is not selected here. So we are doing the calculation for account department. So for account, above the account department we do not have any roof na, because we have first floor above that, so just leave it. Now here in floor, when you come, so your floor is above condition space. Floor is above, if your floor is above condition, means ground floor, account department floor is above condition space or unconditioned space. So our floor is above unconditioned space na, because we are starting from ground floor. For account department I am talking. So you have to write down the floor area, floor U value, everything here. Okay, ambient temperature is what? So we know that for Hyderabad 107, unconditioned space 102, and ambient temperature, that you have to write down here, detail whatever. Then come here next, partition. So yeah, in our project we have any partition wall? Yes, we have. If you want to confirm, see, open the Revit and see here, when you open the ground floor of account department, partition wall means what? The wall which is coming between condition and unconditioned. So corridor, this wall is acting as a partition wall. So what is the area of that wall? So use the di command, measure the area from here. See, like this you have to measure. See, it is showing 24 point something. I don't want in fractional and feet. So okay, select the unit. In length you have to just change as a, you want to see this detail only in feet. Okay, select the feet. You can take the symbol also from here. Now see, it is showing 24 feet. Okay, so it means the length is 24. Height, how much we have to take? Up to false ceiling height, it is 10 feet na. 24 into 10, 240. It means we have partition wall area 240. So that detail you have to write down here, 240. And the U value for wall partition, whatever. So when you open the Astro handbook, you will get that detail 0.4. Okay. So here I have written in the Astro handbook. Now here also you have to change it 107 and 102. Then here I am writing 60. All of you know that in winter season, if your room temperature, suppose outside temperature is 55 in winter season, so when you come inside the room, so temperature will increase a little bit more than outside. So how much more? 5 degree Fahrenheit as per Ashray. If you have a ceiling partition, suppose any ceiling is coming between conditions, so you have to give that detail also. So here I have taken that value. Finally you have to hit on that. So in this way, when you have done the changes, so maybe your TR, cooling load value, will be increased. Okay, so in this lecture we have to discuss how to transfer HAP report to Revit. So suppose in HAP you have done the changes, whatever heat is added you have added, like in account department I have done the changes some, you know that I have given the wall partition also. Okay, I have taken the partition and everything. So okay, now you want to transfer this HAP report to Revit. So what you have to do? So for that you have to open the Revit software first of all. See, before transferring the HAP report in Revit, see the TR is showing for account department is 1.1 and supply airflow 533 CFM. So for that now, here also the first point, we have to create the space schedule for HAP heat load calculation. So how to create, all of you know, analyze tab, report and schedule or quantity. So under, just select that schedule and quantity. Under category you have to select the spaces. So see, I have selected spaces. Now write down the name is space schedule for HAP heat load calculation HLC. Hit on OK. Now what parameter you want to see in that schedule, just add it. Let's say I want to see the level, so I have selected level, add it. Now I want to see the name of that space, number, so whatever you want, area. So where is area? Select area. And now I want to see the design cooling load, design heating, whatever, just design cooling load. Now I want to see the specified supplier airflow rate, just add that also. Anything else, just add it. Okay, then finally hit on OK. Do the setting as I told you, in sorting and grouping, sort by level. All of you know I want to see the level in header, footer. Here select the total only. If you want blank line, select the blank line. Okay. Okay, now you want to hide the level, area you want to see the, so in formatting just select the level, in field formatting check hidden. Okay, getting, you want to see the area, so same in formatting only select the area. Here in this list you have to select the calculate total. Okay, now see the area is visible. So in this way also you have to create the space schedule for HAP heat load calculation. Same way, close it from here. Now see, here we have created. Getting? We have created the space schedule. Close it. Now same thing, if you we have to change the space tag also for HLC. Okay, because I want to see, now I want to see the whatever after the changes, whatever cooling load and CFM is coming, I want to see that. So we have to change the space tag for that. So for that, select the existing tag. Okay, I will just show you for this tagging. Select, because we have done the changes in account department. So for that, remember the TR and CFM. Select the tag, existing tag, modify tab, edit family. From here you have to select the label. Edit label option is given, select it. Now here you can see design cooling load, just already calculated cooling load or calculated supply airflow is for which we have done in Revit software, whatever heat load calculation we have done. So for that, if you want to see in this tagging only, you want to see the cooling load and specified airflow for which you are doing after the changes. So just add design cooling load, anywhere it is given design cooling load, add that also, and then specified supply airflow. Okay, I have added, remember, okay, design cooling load and specified supplied airflow. From here just write down 0 only. Okay, suppose this is this when we have done the changes, after that when we are transferring the HAP into report. So I want to see that detail here in design cooling load. So check the break, let's say, then apply. Okay, okay. So from here, save file type, save as family. Just for your understanding purpose, I am showing here. Save it to the desired location with the name space tag for heat, space tag for HAP heat load calculation for HAP. I am writing here. Now save it into the desktop. Now finally load into project and close like this. Okay, now open your floor plan. How much the result you will get from the HAP. So for that you have to check the result. Now here, if you want to check the result, okay, we have done everything. Here in system also you have to select, hit on new default system. We are using AHU, so write down the system name AHU. Equipment, we are supplying chill water air handling unit, let's say, and system we have taken VAV system, if you remember this thing. Number of zone is depends on what number of spaces. So here I am selecting only one space now, because remember we have a multiple space but we don't know the quantity. I want to show you only for account department. Now in second system component, in duct system you have to take the 10% heat gain value, 5% duct leakage from here. Now return air is going through ducted. Okay, ducting, so select it. Now come here in supply fan. Here you can select the fan type and whatever configuration is total static. If you are using AHU, so 2-inch water gauge, select it. Okay, and then finally come to next one, zone component. In zone component write down VAV 1 and you can select the room. Account department only I am selecting, okay, because I want to see the detail. So as per your requirement you can select. Then sizing data, 10% safety factor for cooling sensible, cooling latent, and for heating if you want to give. Okay, then in equipment no input data required, so hit on OK. But see here one error is showing. Okay, so means we have to create the schedule for thermostat. So create a schedule. Here you can write down thermostat like this, and thermostat, hit on in schedule type, hit on fan or thermostat. Okay, okay. Now see, if you want to see the result, right click, print view designed result, hit on that. Now see, the result is ready. If you want to see the preview, see the preview of that result. Okay, if you want to open the next page, from here hit on next page where it is account department. See, space load and airflow VAV system we are using. Cooling sensible, now it is showing 15.6, means in MBH. If you want to convert in TR, so you have to divide by 12. So 15.6 divided by 12 is how much? When you do now, you will get around 1.3 TR. It means after the changes 1 TR, airflow is now increasing. See why? Because we have added partition wall detail also. So okay, Cooling load is 1.3 TR. Supply airflow value is 769. Now you have to do the changes. Open the Revit. Here, come here. Okay. So already we have created that. Do the changes in here. First, you have to just select the existing tag, replace it with updated one. Where is, see, space tag for HAP. So now you will get that detail also. So here you can change that value from here. 1.3 TR it is showing now, and the CFM is increasing and showing 769, I think, in HAP report. Okay. So now see how much changes is when you have added the partition wall details. So see, here your CFM will increase 769 now, and TR is also increased 0.2 ton. So in this way, that is why I'm telling Revit will not take all detail like partition wall and everything. So when you add this detail now, so your TR means cooling capacity and supplier CFM will increase. Okay. So in this way, you have to transfer the HAP report. Same way for each and every room you have to do it. Okay. So this is all about how to transfer HAP report to Revit. I hope all of you enjoy the session. See you in next one.